Eric Burgess here. We have been given the following equation and we were told to solve for m. So in this case, our first goal, right? Well, let's get m on one side and everything else on the other side. So we're going to take this n to the 3/4 and move it to the other side by simply subtracting it to both sides, right? Because it's positive on this side. So we're going to put in a -1. And if we do it on one side, we got to do it on the other to maintain equality. And we are left with, because those two will simplify to 0, m to the 3/4 is equal to 1 minus n to the 3/4. Now we can't stop here because if we do, sure we've got m on one side, but they specifically asked for m, like m to the first power. So we need to keep going. So we notice here that we've got a fraction. And the way you can get rid of any fraction and reduce it to 1, or simplify it to 1, is to multiply by its reciprocal. So the way we multiply by reciprocals for powers, right, is we just raise them to another power. So we're going to raise it to the 4/3 power, the reciprocal of this, the flipped version. And if we do it to one side, we have to do it to the other. So 4/3 on this side. So we're going to get that m, because this will simplify and this will simplify, and it all simplifies down to 1. So this is just m now, is equal to 1 minus n to the 3/4 raised to the 4/3. Now, you might be tempted to distribute this in. Completely illegal move. Because remember, this tells us how many copies we have to do. There is another way to write this, however. We can write it like this. M is equal to, and we could write it as a radical. And this will show you that you definitely can't distribute it because this is an equivalent way of writing it and it doesn't match up at all with the idea of distribution. So the bottom number is 3, so that goes in the middle or in the square root thing. So we get a cubed root. And then we're going to get 1 minus n to the 3/4. And this is going to be raised to the power that's on top. So that's raised to the 4th. In fact, we could go a step further. This would be my answer for the record. This is what I would write down on my paper. But all of these other ways are equivalent ways of writing it. You could also write it like this. You could write m cubed root, and we could do it twice. So we'd have 1 minus another cubed root of n to the 3rd power. And this whole thing is raised to the 4th power. Oh, I've got a mistake here. Good to catch those. Easy way to make mistakes too, writing them this way. This should be a 4, right? Because the bottom number, that goes to the root, and the top number, that goes to the power. Just like how we have 3 in the root here, and 4 in the power here. And we keep that consistent. So there was a mistake. But as you can see, the radical forms, these are valid answers. These two forms are valid ways of writing the solution. It's just they look quite a bit more complicated. It's not entirely clear what's going on. And so the fractional forms are great because when we have an exponent with a fraction, we can use all the powers of fractions to manipulate those things, where here, this is just a lot more complicated. So sometimes you're going to want to write them out with radicals. There are cases where it actually is more intuitive. But as you get further and further along, you're going to get way more comfortable with fractional exponents, and you'll sort of see why. Because fractional exponents, you can tell what you're supposed to do. Whereas with the radical form, it's just way harder to tell what's happening. So most of the time, you'll actually convert to fractions so you can just manipulate things easy. If you have any questions about this, feel free to drop some comments down below. Subscribe. If you're a Citrus College student, feel free to stop by online tutoring. We're there to help you out, and we'll catch you in the next problem.